Okay, this lesson is on rational functions. So we're going to learn how to graph rational functions and also identify holes in their graphs. So a rational function is going to be a polynomial divided by a polynomial. So here you can see that it says p of x and q of x are polynomials. The key thing here is that this polynomial in the denominator does not equal 0 because I can't divide by 0. Okay. Here are the steps to graphing a rational function. There's quite a bit more that you have to do. First, you're going to want to simplify the function. Once you do that, you're going to find the x-intercept by setting the numerator, the top, right, equal to 0. And then the third step will be to find the vertical asymptote or asymptotes by setting the denominator equal to 0. And then after that, you're going to try to find the horizontal asymptotes. And there's some rules here to follow, which I will paste on each slide here so that you can kind of see as we go. And then lastly, you'll have to identify any holes. Okay, so it's kind of a lot. We're going to just practice this and hopefully you'll get the hang of it. Before we do that, I just want to talk about what is a hole in a function. So a hole in a function is like something like this, where you graph something and let's say it's linear, or it might be a hyperbola, but in some spot in there, there's actually a break. There's a little hole in there, and oftentimes we'll indicate that by putting an open circle, something like this. So this is like a line, but it's got a hole in the middle. And again, this could be a linear function, or you might also see this with, maybe it's like a hyperbola. You got a branch here, and then you have a branch here, and you might see a spot in there somewhere where there's a hole. Okay, so how do you know when there is a hole? Okay, so that's what it is. It's a break in a graph. So this occurs when you have a common factor between the numerator and the denominator. So if you look at this f of x function, sorry about that, there we go. If we look at this f of x function here, there's a common factor here of x minus 5 and x minus 5. So those cancel out. So when you simplify this, you really end up with just like x plus 7 over x plus 1, right? But truthfully, before, you still had one of the times where in the denominator here, x could not be equal to 5. So that's still the case. I still have this situation where x cannot, I cancel that factor out, but still my original function has that as a true thing. I cannot have x equaling 5 here. Okay, so if I want to find out what the common factor is, I'm going to set that common factor, or what the hole is, set the common factor equal to 0. So in other words, this, I know that x cannot be 5, or my common factor is 5. So that's my x value. And then my y value, I'm going to substitute it in to the simplified function. So that would be, we'll do a different color. That's this. So if I plug 5 in for x, I'm going to end up with 12 over 6, which is 2. So in other words, this is your y. So where do I have a hole? I have a hole at 5, 2 in this function. So I would graph this, and then at the point 5, 2, I would put an open circle. Okay? Kind of weird, I know. We'll explain this a little bit better as we get into some of these other graphs, and we're going to practice this a number of times. Okay, so here's our first one. Okay, so the first thing I want to do is simplify the function. That was step 1. Now this function right here is already simplified. There's no factoring I need to do. There's nothing really there. Okay, cool. So step 1 is done. Step 2, find the x-intercept by setting the numerator equal to 0. So my x-intercept then, what would make that numerator 0 is when x is 4. So that is your x-intercept. So it's going to be 4, also known as 4, 0. That's my x-intercept. Okay, so I'm going to actually just plot that on here right now. I know this graph is going to cross there. Okay. The vertical asymptotes is when the denominator down here is set equal to 0. So this would be, my vertical asymptote would be when x is equal to -4. Okay, cool. All right, hopefully we're tracking with that. I would maybe also, let's do that right now. -4. I'm going to put my vertical asymptote in right now. Okay. Let's just do this. All right. Now, horizontal asymptote, I have to use this chart down here. So I want to look at the degree of my p polynomial. That's the top one. The degree of this is 1, right? Because there's a 1 exponent there. The degree of the bottom is also 1. So that's the q. So the two are the same. So then I'm looking at this bottom one. The degree of the p polynomial and the q polynomial are the same. So then I look at the leading coefficient of, if we look over here, the leading coefficient of p is 1. The leading coefficient of q is also 1. According to this, I just do that 1 over 1 to find my vertical asymptote. Okay, so my vertical asymptote, or I'm sorry, my horizontal asymptote is when y is equal to 1 over 1, which is just 1. Okay, so let's switch this to red. So I have a horizontal line . Oh, let's redo that. Right there. Okay. All right, now, do I have a hole in this one? I don't have any common factors that were canceled out in here. So like if you have some common factors over here that you end up canceling out, right, then you would have a hole. In this case, I don't. So I know that here I'm just going to write none. My domain, well, x cannot be equal to -4 because that's where I have a vertical asymptote. So I'm going to say x such that x cannot equal -4. My range would be y such that y cannot equal 1. Cool. All right. There, we've done it. Now I'm just going to plot some points and do this. So if x is 0, I would get -4 over +4, so that would be -1. And if I just plug in a couple of other ones, I get something like this. Okay, so now I'm going to try my really sweet branch drawing here. Well, that's not too bad. All right. And you can plug in some other points. Let's see, if I do -6 maybe, I would have -10 on top over -2, which is 5. Well, if I just plug in some other ones, you kind of see, you get this pattern here. Just try to find 1 or 2 points and then draw a branch so it's about in the right spot. I like to have a little bit more than 1 point, but okay. There is my hyperbola, and hopefully that makes some sense. Okay, so this is really just a little bit more work than our reciprocal ones, but I just wanted to go through a few examples here where you end up with some trickier stuff, so you know kind of all the different ways you're going to run across this. Okay, so here's our next one. Graph the function, identify its key characteristics. All right, the first thing is to simplify the function. There's not a whole lot to do other than to set the top. Maybe I could factor this, but that's not really gonna, this is 2x minus 3. Okay, so that's what the numerator really is. So simplify the function, that helps. Now for my x-intercept, well, so then what is that gonna be? When's that gonna be 0? When x is 3. Right? Okay. So 3, 0. Okay. And then when is the denominator equal to 0? That's your vertical asymptote. That's going to be when x is equal to 1. You may start working on domain there. If you have a hole, though, that'll be a little bit different, so you might want to wait on that. Yeah, and then your horizontal asymptote, again, the degrees are the same. They're both 1. So then I'm using this down here. Okay, so my leading coefficient of the top would be 2. The leading coefficient of the bottom is 1, so that's 2. So my horizontal asymptote is at 2. Do I have a hole? No, because I did not cancel out any common factors, so this is still going to be none. Okay. And then my domain, x can't be equal to 1. So x such that x is not equal to 1. And then my range would be y such that y is not equal to 2. Okay. All right, so x equals 1. Okay, and y equals 2. All right, and then I want to plot a couple of points. Well, I already have one here on the x-axis. If you do another one, I like to just try another one. You end up with a point here and kind of a point down here. So that also transfers this way. So then there's one of the branches. There's the other. Okay. There we go. Hopefully that makes some sense. All right. Let's try another one. This one is gonna have a hole. So I'm just gonna say that at the beginning. So you're gonna find out why here in a second. But the first thing I wanna do is, as always, step 1 is to simplify this function. So I'm going to simplify at the top. I don't have a ton of simplifying to do. but the denominator, I have two numbers that multiply to be 20 but add up to be 9. That's going to be 5 and 4. Okay, so now I'm going to simplify. Cancel, cancel. So I'm left with 1 on the top as a placeholder, and then x plus 4 on the bottom. Okay, now because I did cancel a common factor out here, I will have a whole this time. All right, now my x-intercept, I look at the numerator and I try to plug in to make that 0. Now you'll notice that doesn't happen. There's nothing to plug in to make that 0, so here my x-intercept, this does not cross the x-axis. All right. You're going to see why in a second. My vertical asymptote is when the denominator equals 0. So that's this down here, and that would be when x is equal to -4. Okay. My horizontal asymptote, I need to use this chart down here again. So the degree of the top is 0. The degree of the bottom is 1. Okay. So if the top, P, is less than the bottom, Q, your horizontal asymptote here you can see is y equals 0, also known as the x-axis. So I'm going to write y equals 0. Okay. Now I'm going to sketch these in here right away. And then okay. All right, so this is sort of your guide. Now, as I mentioned, I do have a hole for this one. Okay. So how do you find the hole? Let's write this over here, hole. So what you want to do is set the common factor equal to 0. So that, remember, this was the common factor x plus 5. So when does that equal 0? When x is equal to -5. So I know my hole is at -5 comma something. Okay, so I need to figure that out. So then you're going to plug in -5 to the simplified version. So if I do that, I'm going to get 1 on the top, and then -5 plus 4 is -1. So I really end up with 1 over -1, which is -1. Okay, so that is where the hole occurs in my function. Okay, so I'm going to write that over here. -5 comma -1. Okay. So I need to keep that in mind when I graph. I have to make sure that that's obviously there. Okay. My domain, let's do that first. The domain, okay, so normally we just copy this, but now I also have an additional spot that x can't be, and that's when x is -5 because there's a hole there. So the domain here is when x, such that x cannot be equal to -4. Oh, I don't know what happened there. They're -4, but also -5, right? Right here. So that also is the case. So also -5. So those are two spots that I can't have. And then my y, my range would be y such that y cannot equal 0, and also this one, -1. Both. So just be careful of some of those things. Don't forget about the whole part when you're writing your domain. All right, so now I want to graph. Okay, so if you plug in to this function, -3 in for x, you're going to end up with 1. And I'm just going to, that's kind of good. Now you also have this here, but there's a hole at that spot. So I'm going to sketch it and then we'll put the hole in there. This just kind of goes close to here, travels close to the asymptote, doesn't actually reach it. Now, same thing here. Okay, now at this spot though, I have a hole, so I do have to take care of that. So I'm gonna do that, and then we'll just, I want to make sure that that's kind of obvious. I have a hole there at -5, -1. So this is a continuous branch on each of the branch, but then it breaks. So then that makes it discontinuous. And we also have another part where it's discontinuous at this hole here. So kind of weird, but that's what that looks like. Okay. All right, well, I want to try 2 more cases just so you see how this functions, and then that'll be it. Okay. And again, I'm going to start by simplifying. Go a little faster with this one. I'm going to switch colors too. This one will do pink. All right, in the numerator, 2 numbers that multiply to be -28, but add up to be 3 would be 7 and -4. And then the bottom, 2 numbers that multiply to be 35, but add up to be 12, 7 and 5. Okay, these cancel. I get x minus 4 over x plus 5. Okay, so if I look at the numerator and make that equal to 0, that gives me my x-intercept. So that would be, when does this equal 0, right? That would be when x is 4. So my x-intercept is 4, 0. All right, in the denominator, that's my vertical asymptote. So this would be when x is equal to -5. Okay. And then, all right, now I need to do my horizontal asymptote. Now, the degree of both of these is the same. You'll notice that you can look at either one, the original one or this one that you've simplified. The degree is the same. They're both 1 here and 1 here on the bottom. So then I go back to this and I look at what is my leading coefficient of P and a leading coefficient of Q. So that's going to be 1 over 1, which is 1. So my horizontal asymptote is at 1. Okay. And then the whole. Okay. So the common factor that we took out was when x, or x plus 7. So that's when x is equal to -7 is when I'm going to have a hole. So I know that I have a hole at, I could write it, I guess, over here, -7 comma something. Okay, so now when I plug in -7 into this, what do I get? Well, I would have -7 minus 4. And then I would have -7 plus 5. So now if I do that, that's 5.5. Okay, so over here, I have a hole at -7, excuse me, comma 5.5. All right, So finish this up by doing my domain. Ooh. Let's try that again. X such that X cannot be equal to -5 and also -7, because that's where my hole is. So -5 and -7. Range Y such that Y cannot equal 1, right? Yep, that's my horizontal asymptote. But also my hole, the Y value of my hole is 5.5. Okay. And then now it's just time to piece all of this together. So, all right, let's try. Let's put, a vertical asymptote at -5. And then a horizontal one at 1. Okay, cool. And then I want to graph some stuff. All right, so I know I have an x-intercept of 4, 0. Okay, and then I also have another one. Another point would be this right here. And then I'm just gonna kind of draw that branch. That gives me good enough. And then you'll notice there's like 3 units this way. Well, it's gonna be symmetrical that way, so I'm gonna put another dot here. Another one up here. Okay, and then draw my branch. Okay, now I do have a hole at -7, 5.5. So I want to make sure that's in here. We're just going to identify that. There. And there we go. That's that graph right there. Okay. I would like to do one more. I hope this is making some sense now. All right, I'm going to simplify. Here we go. All right. If I simplify the numerator, 2 numbers that multiply to be -5 but add up to be -4, be -5 and 1. On the bottom, I have a 2 as a common factor. So if I pull that out, I'd end up with x plus 1. Okay. So then these common factors cancel out. This means I will have a hole. Right now I'm left with x minus 5 over 2. Okay. In the numerator, if I set that equal to 0, that gives me my x-intercept. So that's going to be 5 or 5, 0. Okay. Vertical asymptote is when the denominator equals 0. So I look at the simplified version here. This, not the other one. This is when I don't have one. Okay. Horizontal asymptote, I'm going to look at the degree. Now you'll notice that the degree of the top is bigger than the degree of the bottom. Okay, again, you can look at the original or the simplified version. It doesn't really matter. If the top has a higher degree than the bottom, then you don't have, you can see here, no horizontal asymptote. So this also, there is no horizontal asymptote. Okay, now I do have a hole in this case. It's when x is equal to -1, okay? So I know -1 comma something. So if I put -1 into the simplified version, in other words, put a -1 here, I would get -6/2, which is -3. So that's the other part. Okay. Now my domain, whoops. Let's do this such that x cannot equal, well, I don't have a vertical asymptote, but I do have this spot where I can't equal, and that's at -1, so cannot be equal to -1. The range, again, I don't have a horizontal asymptote, but I do have a y value. Okay, so cannot be equal to -3. All right, now, how do I graph this? Okay, well, this is a vertical line. I mean, a linear function. Not vertical, but it's a linear function, y equals mx plus b. Another way to write this would be y equals, right, this is a 1. So this is really 1/2 x minus 5 halves. If I divide each part by 2. So -5/2 is just -2.5. So this, that's my y-intercept. And then my slope, or maybe you could just say my y-intercept or my x-intercept is 5, 0. That's good enough. This is a linear function. All right. So I don't know how great this is going to be. There we go. Pretty good. All right. There's my linear function. Okay. Now remember, I have a hole at -1, -3, which is right here. So I need to make sure that I sketch that in. There we go. There's my function. It actually looks like a linear function, right? There we go. Okay. I hope that this is starting to make some sense now. This is your assignment. You can turn it in when you're done. Don't forget to write into your planner. Good luck.